From transport to energy, from water to communications, infrastructure networks are vital to the operation of our day-to-day lives. When these networks fail, whether in a conflict, natural disaster, or due to some other event, the economic and social consequences can be major. In addition, cascading failures occur, which result in complete social collapse. Therefore, understanding infrastructure interconnections and addressing their resilience is an increasingly important humanitarian issue. SmartResilience project addresses resilience in the modern society as determined by its various and often interconnected infrastructures. SmartResilience assesses and increases the infrastructure's resilience by focusing on three major pillars. 1. A knowledge base. 2. A comprehensive method and multidisciplinary tools. 3. 8 case studies. A virtual scenario of a tainted flood illustrates that infrastructure owners often lack insight into external infrastructures in their proximity, which might affect them and rely on their own service delivery. India is such a case study, combining a wealth of different infrastructures and threats. Bravo Town is a smart city with a number of interconnected infrastructures. Echo is the town's oil refinery located in the industrial zone. Critical infrastructures are interconnected, and with the assistance of big data analysis, these interconnections can be tracked down. An assumed event like an explosion at Echo has an extremely low likelihood due to the continuous preventive measures carried on. This assumed event would affect not only the surrounding area, but also other critical infrastructures. Injured people would flood Charlie, the town's general hospital and one of the largest in Europe. Further transportation problems would appear at Delta, the town's airport. The airport regulations impose that in case the security of the individual staying in the terminal cannot be guaranteed, the terminal has to be evacuated in a way that it does not bring the evacuated persons in greater danger. More than 1,000 people trying to evacuate. Drinking water provided by Foxtrot would suffer microbial infestation as rain washes dangerous substances into the water supply. Golf. At the same time, heavy rain could start, causing pluvial and tidal flood all over Gulf, the town's district which is located at the mouth of the river. At Hotel, the town's energy storage and supply, self-ignition could strike, not only further polluting the atmosphere, but also disturbing district heating, cooling, electricity, and even public health. The SmartResilience knowledge base provides a number of tools that are valuable for the resilience assessment of interconnected smart critical infrastructures. These include a glossary with terminology and regulations, as well as a resilience indicators database. The indicators database of SmartResilience can be used by a wealth of different critical infrastructures and for different potential threats. It can be completely customized to each user's needs, and for better results, it even includes indicators derived from big data analytics. The resilience curve describes the functionality of a critical infrastructure before, during, and after an adverse event. There is, however, no way to directly measure this curve. Thus, indirect measurements are used. This provides a baseline resilience assessment of specific threats, specific smart critical infrastructures, or an entire area or city at a certain point in time. Interactive visualization supports understanding and intuitive analysis of the resilience level without the need for special expertise.